For this problem, we are given that theta is normally distributed in 0 and 2 pi. So we have the density function of theta is equals to 1 divided by 2 pi, when theta is from 0 to 2 pi, and it is 0 otherwise. And we are also given that n1t and n2t were wide side stationary, so are wide side stationary. So we have the expectation of n1t is constant, and similarly the expectation of n2t is also constant, and we also have the expectation of n1t plus tau times the expectation of n1t is equals to r tau, and it is also a constant, and similarly for the n2. This should have the notation of n1 and n2, and this is what we get from the question gives us, and I will make it smaller. And for the A, we need to find that the expectation of EZ, where Z is given in the problem. So we expand this formula, we get that the expectation of EZ is, we plug in the equation of ZT into the formula. And we can take the expectation of n1t out, and it is a constant. Times the expectation of cosine omega c times t plus theta. And similarly, we have our second term. Which is the expectation of n2t times the expectation of sine omega c t plus theta. And this is also a constant. And since we have that the expectation of cosine, this one is equals to 1 divided by 2 pi, and the integral of 0 to 2 pi cosine omega ct plus theta. Here is the theta, and since it is a periodic function, so we have this term equals to 0. So here we have our result is equals to 0, because this term and this term is 0 due to its property of periodical. And this is for problem A, and I will also make it smaller. This is for the problem A. And for problem B, we are told to find the autocorrelation of ZT1 and ZT2. So we just plug in the formula of RZ. It is equals to expectation of ZT1 times the expectation of ZT2. And we just plug in the representation and we expand. Here I will omit some steps, so we get our answer is expectation of N1 T1 times cosine. We will have 4 terms in total. I just write down the formula. And it is the third term. It is a fourth term. And based on the stationary property of N1 and N2, we have this term is equals to R2 R N2 tau, and it's a function of tau. And also this term, it's equals to Rn1 tau. And as we have derived from the previous section, we have this term is constant. Here also this term constant, and this term constant. So based on our formula, we get that, and also we need to, and based on this formula, we can rewrite the equation to be, let me make this part smaller again. And it is equals to Rn1 tau times the expectation of cosine omega ct1 plus theta times cosine omega ct2 plus theta plus I just rewrite and simplify the equation I get in the above step. And at this step, we need to apply some equation of triangular mathematical expressions, and we can know that to simplify this term, it should equals to 0.5 times cosine plus cosine omega c times tau, as tau is the difference between T1 and T2. And similarly for the other four terms, I will just write two terms because of the space limitation, and this term is equals to and finally, after we simplify this equation, we can get our answer is equals to Rn1 tau plus Rn2 tau, which is a constant, and tau is the difference of T1 and T2, and times cosine omega c times tau. So we can see that it is a constant. So we can derive that ZT also have the property of WSS, which is the wide sense stationary. And let me make this part smaller. And for the question C, we are asked to find RZ0, so we just plug in 0 to be tau, which indicates that T1 is equal to T2. So here we have one zero times Rn2 0 times cosine 0, which is equals to 1. And since T1 is equals to T2, so we have it is equals to the expectation of N1T square plus the expectation of the square of N2T. Since T1 is equals to T2, and this is our answer, and this should be. So this is for the problem 7. For this problem, I think we should apply the property of WSS. So we should make the property of these two and apply in our equation at here. And we will also have some triangular representation which can simplify this function. And that's for problem 7.